In this video, we will be constructing and building an A-stable multivibrator. The planning has been done in a previous video. Check in the links below for planning and layout of an A-stable multivibrator. So there's parts, we will place it on a Vera board according to the planning as laid out. I've got the parts laying next to the planning, and we must confirm the track side and component side of the Vera board, and we can immediately start placing the components according to the planning. Obviously, component side, I will start right away to placing, and you will see that I am not using any type of tool. I'm just bending the legs by hand. Simply, I don't want to damage them. Just in case I install them wrong, you pull them out again and bend them again, and that could cause the legs to just break off. You can see I'm placing according to the planning as accurately as possible. The planning is supposed to be an exact replica of what you would do when you are physically placing the components or doing the task. So I am at this point with the first part of the circuit. I've got my transistor placed, I've got my capacitor in there, and now I will put R2 in place, which will connect with my capacitor negative leg, and again making sure that the tracks are clear electrically. You will see on top I am busy with R3 already, and all those tips on top, I'm at the third connection on top there. And I will just go through the whole project by looking how I have planned it and placing these components identically or exactly as I did according to my planning. LED number 2, it could be too red, it could be too green, doesn't really matter. It is just nice to have a variety of colors. The transistor will take maybe some doing to get in there. In this case, the legs are not far apart from each other, so you don't have to struggle that much as within other projects where the legs have to stretch pretty far. And in the case of these type of projects, for assessment purposes or assignment purposes, you are not allowed to put any jumpers on the board. As I place them, the legs on the track side are also just bent across so that if and when I must solder, they don't fall out. Please also check video on placing components. That would be of an assistance when you are placing these components. So at this point, I'm confirming that my tracks are clear, my connections are accurate, and maybe there is maybe one issue or two that you will pick up because you maybe were in a hurry, and this is why the planning is important. You can see there maybe R3 could do some changing there. There's an issue with R3 already, and if you confirm there the capacitor is negative and R3 is not as per plan, so again take it out and just reinstall it correctly. And this is why you can't just rush into these things. Planning is important, and this is how you can fix a problem that can cause the circuit not to work. So that looks good. The project is ready to be soldered or finalized. I will get ready for the soldering, and again there we have a soldering iron, some solder. A side cutter would be advisable to cut the legs at the end. Tip must be the correct heat, and you should have a sponge with your soldering iron. And so at this point in time, you place the project upside down and you can start soldering. Please check the video on soldering techniques. There is a few tips there on how to solder, and tip right against the leg as it comes out the hole, and you gently just apply the solder to the tip, and you should be having a good bond. Generally, these projects can be put in some sort of a vise that would stabilize it a little bit more. But again, if this type of assignment is done under supervision and you have a time frame in which you must complete this task, then you must just do with what you have. And so it's always good for these legs to be bent, that they don't just pop out every time. So it's all about technique and practice. And so after we think we have soldered, we should just confirm that all the points are soldered by turning the project with the components facing you and just looking at the legs where they connect onto the track, and make sure that they are in tight. You can easily just see by just nudging on the components and making sure that they are not loose. If they are loose, you would probably have missed a point, or it's not soldered properly, and so at this point maybe one or two items. I think that should do it, and those legs can be cut off. Again, 1 millimeter clearance both sides, so when it's done the component should be 1 millimeter clearance away from the surface on the component side, and also sticking out 1 millimeter after the little legs are cut off. There I just use a side cutter, and I'm keeping my finger on top for the parts, the loose parts, not to just jump away, just falls onto the paper. And so there we have a finished product. It should now be ready for testing. There should be another video after this for testing the circuit and recording the readings. That concludes this session.